Now let's plot the graph out of the data which took a log2 function and then see the behavior of the function. So let's set that t of n means execution time of n data. Then let's put it into a y-axis. So we have linearly marked there. In x-axis changed linearly, but it's a log 2 base n data, and the y-axis is log 2 base of t of n execution time, and it also 2, 3, 4, 5, 6, 7, and the like. Then as we have 1k data is marked here, and 2k data is 1 point, and then 4k is 1, 2, 3, 4, and then 7 is 8k here. So it's approximately linear line. And then what is the slope of this line? We can find that from math. We learned that suppose we have 2 points in the 2D plane. So we have x1, y1, and then we have x2, y2. And then this is line connecting 2 points. Then slope is defined as y2 minus y1 divided by x2 minus x1. Difference of y, difference of x, division, that is a slope. So in this graph, x2 minus, if we find the slope of a next adjacent one, so here this is a 1k data, as you can see, is a 2k data, 3k, 4k data. So in this graph, what is the slope between 1k and 2k, 2k and 4, 4k and 8? We can compute the slope of each segment. The x2 minus x1 is always 1, so we just compute the difference of y, which is times, if I keep marking that. So this one is x location. This is y in the graph there. So let's compute the slope. 1k to 2k is y2 minus y1, and then 4k to 2k to 4k, the slope is y2 minus y1, and then similarly y2 minus y1 is a slope. So let's just assume for simplicity's sake it's close to 3. So let's say slope is 3 out of this empirical experimental data. Then the equation of this graph is y, something like y is some slope times x plus offset c. That is a general equation of a linear graph. Then y is log 2 base t of n, and then slope is 3, and then x is log 2 base n, and then some offset. So that is the representation of the graph. Now we want to eliminate log 2 by applying exponent 2 power of this thing and 2 power of this thing. Then equation remains unchanged. Then left hand side of the assignment, exponent and then log 2 cancels out. So left hand side is t of n. And then for this is this exponent plus means we can separate into 2 power of c and times of the 2 terms. So on left side term, so also the 3 times log n, 3 can go up as n cubed. So now exponent 2 and log 2 cancels out. This is n cubed times 2 to the power of c. So that's another rearrangement of the equation. So this is a final equation for the line we have. How to find the then unknown c? We have lots of data. We can simply plug in one of the data. So his x, y data is there. By plugging in those values, then now we can solve the constant c for that. So again, x means log 2 of n, y means log 2 of t of n is there. But actual data, actual time is there. So to find 2 to the c, so let's compute 2 to the c. 2 to the c is t of n divided by n squared. N cubed is 2 to the c. So for 4,000 data, we have the one. So for 4K data, what you get is 2 to the c is execution time is 18.76, and then data n is 4,000 cubed. That's 2 to the c. So we find out of 4K data. Now our ultimate goal is what is the execution time prediction if we provide 16,000 data. And here is the equation we find. That is 16,000 cubed times 2 to the c. 2 to the c is 18.76 divided by 4,000 cubed. So if we solve this one, let me try to solve it by a calculator. So let me bring up a calculator. So it's going to be a huge number. So let me first compute this 16,000 cubed divided by 4,000 cubed. 16,000 times 16,000 times 16,000 equal, and let's divide the 4,000 three times. Divide it by 4,000 once, 4,000 twice, 4,000 three times. So 64. So 64 times 18.76. So times 18.76. So that's expected execution time with 16,000 data. So that is approximately 1200. 1264. So 1200 means if we divide it by 60 is a second is 1 minute, then it's about 20 minutes. So what you expect is about 20 minutes to compute some algorithm for 16,000 data. So that one is our estimation from the analysis is 20 minutes. Then will that be it if we actually run it? So in the program, we have created a 16K data, and then let's run it. 3sum 16K data, and then compare it with the 20 minutes. So let me run it, and then it's expected to run about 20 minutes. So what I'm going to do is I'm going to stop recording the video, and then when the computation ends, I will record another video.